Hi, and welcome to Chapter 13. In Chapter 13, we're going to cover web servers and services that are run over the web. Let's get started. As you can see from our roadmap, we're into our alternate access section here. Getting close to the end. We're going to cover web services and servers in this chapter, and next chapter we're going to get into remote access and long distance connections, being able to remote access into servers. The first thing we need to do is make sure we understand the difference between an intranet, an internet, and the extranet or extranets. So there are three different ways we describe these. What most people think of when they think of the internet with an ER, the internet, it's the collection of interconnected networks all around the world. We call this the World Wide Web. These are public sites that you can go to without authorization. So you can choose to type in www.google and you'll get to the Google site. You can choose to go to Microsoft and go to the Microsoft site. These are public sites that don't allow or don't require any authorization. So it's really important to understand the difference specifically between an internet, which is where everything is public and available, and an intranet. An intranet with an RA in the middle is a private network that specifically serves a specific group of people or users within a given LAN. It can't be viewed from the outside. You have to be inside the LAN, inside the firewall, inside the network to be able to reference these. They're still websites and they're still designed using HTML and CSS and JavaScript the same way any other website would. We're going to get into that in just a second. But these are inside of your LAN. This is where companies are going to put things that they want to keep private just inside the corporation. They don't want these to be public knowledge. So your intranet is going to be things that you keep personal. You usually have to log in or at least log in from inside of the network. Although sometimes people need to get to this information from the outside, and that's where an extranet comes in. An extranet allows internal access to these websites by allowing you to log in from the outside. So rather than just going to Google and getting the main page there, if I wanted to get into the intranet of Google, I could go through an extranet website from the outside and be able to log in, authorizing. Extranets allow people outside to log into those intranet sites. So the intranet is internally inside your network. You cannot access it from the outside. To access it from the outside, you would use an extranet. So that's how these three concepts of different networking websites are going to work. Your internet, which is your World Wide Web, everything connected, everything public. Your intranet, inside of your LAN. And your extranet, the way to get from the outside into your LAN by authorizing. I'm sure most of you understand domain names, so we're going to cover this quickly. A domain name is a part of the URL that is going to describe where are you going. This is going to be connected to a specific IP address, going to a specific location on your web server. When you connect the domain name, you also need to use a protocol. Most people will type HTTP instinctively, not really thinking about the fact that there is more than one protocol. Obviously, most of us use HTTP or Hypertext Transfer Protocol. We'll talk about the protocol in just a minute. But there is also a secure version, HTTPS. There's also file transfer protocols and other options that you have for the protocol of your domain name. If I wanted to use FTP with my GW site, I could do an FTP www.gw.com and then go to a specific directory, assuming that I could log in and access that FTP site. Some FTP sites are public, they're available to anybody. Some are private behind a firewall, some version of authentication. From our domain name, you are going to have a series of directories that we call the path. It can be none, it can be one, and it can be multiple. It depends on it, and we've covered this in previous chapters, so I'm not going to spend a lot of time. After our path, we have what is the resource, the actual page. In this situation, we're referring to an ASPX page or an active server page, an ASP page. You might have an HTML page, you may have a PHP page, you may have a different type of page which has different extensions. If you are using different types of, say, .NET connections for your website, you may not have an extension at all. It may just be a page which will be connected to a view with a model view controller. That's all more related to HTTP website development and not a portion for this class. But that's where your resource is going to come in. After your resource, we're going to have a colon and then the port. Generally, people don't use the port. It's assumed. If you're going to use HTTP, we're using port 80. That's why in the last chapter we talked about which ports reference which protocols. In this case, HTTP refers to 80. HTTPS, 443. FTP. All of these have different ports that they would reference. You can reference the port directly in your URL, and sometimes it's just not necessary. It's assumed with your protocol, and we can go with that. But if you weren't going to use 80 with HTTP, if you wanted 82 or 85, you would need to put those in explicitly. In other words, they'd have to be printed there as opposed to being implicit, which is the default ports. When we're using a web server, the purpose of a web server is a server that is configured to provide web services. Understand, a single server can provide more than one type of service. You can also choose to have a thin server or a server that is only specified for web services, segregated from the rest of your servers. That's an option as well. But remember, a server doesn't have to just do one service. It can offer more than one service. A website, as I'm sure you know, is a location on the World Wide Web or a location inside provided by your web server. There is a understanding of how it gets from your browser to the web server and back. So we need to start from your computer. I need to say I want to go to this location. It's going to then go over to the web server, ask for what I've asked for, ask for the resource, and serve it back to me. This website is going to be the location on the web that you're going to reference. Obviously, domain names need to be unique, and we've talked about domain names before. So your domain name is tied directly to the IP address of your server, your web server. You can use the Whois utility on the Internet website to actually search for who is this domain name, and it can link you directly to that IP address, given those A records, given the requirements that you need for what is this IP address domain name relationship. You can go to the Whois utility on Internet. You can honestly just type in Whois 172, 131, whatever it is, and it'll go ahead and give you who is that IP address associated with. When it comes to web servers, the two big ones are either Apache or IIS. So Apache is an HTTP server, so it is a hypertext transfer protocol server. It is designed as a web server, and it is provided by Linux or Unix, so it's free, it's open source. And when you, assuming you did, install your Linux machine, you will find that there is an Apache HTTP server already included in it, or you can choose to add it. So the Apache HTTP server is free and comes with Linux. It's designed to be run on a Linux machine. As there are so many web servers running on Linux machines, Apache is a very, very common web server that is used. The other one is Microsoft's IIS, or Internet Information Service. This is provided with every Microsoft device, including Windows 10. But the feature has to be turned on, so you can go to the turn on your features and turn on IIS and run your computer as an IIS server to be serving web pages. If you want to run a web server inside of your home using one of your home computers, you can totally do that. If you have a static IP address and you want to run it from your home and use that from your ISP, that's an option as well, although generally ISPs frown at that if they expect a huge amount of traffic. Obviously, you can also use any of the cloud versions of web hosting if you needed to run a web server. When we talk about outsourcing or hosting your own website, there are lots of reasons to pick one or the other. Again, you can go to Azure, you can go to GoDaddy, you can go to any of the other choices for hosting your website. Differences between them. If you host your website on a computer in your home or in your office, depending on where you live, what your situation is, you can choose to pay a little bit of extra to have a static IP address. Most home networks are dynamic. So they cannot guarantee that the same IP address will be used for you every time. A static IP address would do that. So you would set up a static IP address for your home server and open up that port 80 so that people can come in and out, and then link that IP address directly through a registrar to be able to connect for a web server. You can do that. However, if you host your own website, you have to purchase and install the server hardware and software. Sometimes you need to have an expert, which by the time you finish this class may be enough for you. You may want to have an expert in web server development and administration. The owner must obtain and pay for all of the connectivity. So their cable modem, their T1 line, high bandwidth. If you have fiber, you're probably fine, but you still may have to pay for that extra IP address, the static as opposed to dynamic. Obviously, you're maintaining it. It's your admin and your security checks. So you're making sure no one's breaking in, doing DOS attacks, no one's doing anything bad to your server. You also are going to need some web design software, although in all honesty, you can make a website with Notepad, so that's not as big of a problem. If you want to lean towards building your own website, I would recommend highly taking a course in HTML, CSS, web design, JavaScript, just to make sure you understand how to make your site. The alternative is to have your website outsourced or stored on someone else's server. Generally, the server space used is what's called prorated. If you have to buy your own server, you may have to have, say, a 100 gigabyte hard drive or something like that, even if you only use a gigabyte of data. You're paying for the whole thing. With outsourcing, you're paying for as much as you use. If you only need 500 megabytes of data for your entire website, you only pay for the 500 megabytes of storage space because everything's prorated because everybody's all on the same hard drive, and it allows you to pay for less so you don't have to pay for the whole hard drive, all of the hardware. Generally, these sites have technical support that's provided. Connectivity is obviously provided. They guarantee, so if you go through Azure, if you go through GoDaddy, they guarantee your site's going to be up. You don't have to worry about a storm or power outage at your home or your office. They have redundant systems that are designed to handle that. Most services, such as administration or maintenance, are already done for you. They're going to check security for you. They're going to do maintenance for you. They're going to make sure your server is up and running. Sometimes they offer website design. Sometimes they don't. It depends on the site that you choose from. So you can run a static site on Azure and just pay for storage space, and it's relatively cheap, and you do all the design work yourself. All the way to some of the sites that offer web design for you or offer a wizard or a template that you can use, and this gives you another option. When thinking about web servers, it's really important to decide at the beginning who's going to host your site. Are you hosting it or someone else hosting it? Because it's going to make a difference in cost, development time, and expenses. Some people get browsers and search engines confused. A browser, Firefox, Edge, Chrome, Safari, is an application that runs on your desktop. So you open Chrome, you open Safari, you open Edge. The search engine is actually a program, a software program that is designed to locate websites by relevant terms. This is going to be Bing or Yahoo or Google. These are, although Google is also generally considered a company and a couple of other things, when you Google something, you search for it. You can use DuckDuckGo, you can use Bing or Yahoo or AOL. They still have search engines, and the engine is the software designed to go find the website. One of the most important skills for anybody in the IT field is to be able to efficiently find information on the internet, being able to use a search engine. Recognizing that different search engines provide different results is an important aspect. If you go to Google and you go to Bing and you go to DuckDuckGo and you ask them all the same search question, you're going to get a different subset of results. That will continue to be a thing because every search engine has their own algorithm. The search engines generally use either what were called spiders or bots. They are designed to comb over the World Wide Web and collect information about website content, terms, and metadata. You can add metadata to the top of your site that says these are sites, this site references database descriptions and ERDs and normalization, or things that are specifically related to database design. That's going to go back and tell Google, or whichever search engine you're using, this site, this IP address, this domain corresponds with these words. Then when a user comes in and says, I'd like to search for database-driven websites, something like that, this might come up as one of those possible results. Your ranking, or how high you are in that list of results, is a very closely guarded algorithm. It takes into account how many links from other sites are there, how often is the page clicked when people search on it, how many times does it use these other words that are sometimes related to the words that you typed in. Lots of different algorithms go into it, and each software search engine, software program that builds a search engine, is proprietary to that company. So it's really important to recognize the search engine that is going to produce your results is different for each search engine. There are different reasons to pick one or the other. Without getting into the political conversation, they obviously all have their own algorithm. So you need to take that into account when you recognize that you are searching on a search engine, and that search engine may add extra things into its algorithm that you may not be aware of. Again, that algorithm is always a very closely guarded secret. Nobody knows what's in the algorithm. You can kind of guess, and you can add in some posits on what you think might be in there. There's also a really important part about search engines, which is the sponsored links. If you notice on your search engine, sometimes the top result or two may not be exactly what you expected. And somewhere underneath it, it may have the word sponsored or the word ad. The way that these search engines can make their money is to be able to allow people to say, when you search for this search item, put my item at the top and I'll give you money to support it. So if I was going to search for a competitor to something, specifically if I was going to search for Microsoft, if I were Apple, I might choose to add a advertisement or a sponsored link at the top of all searches for Microsoft, so that people might accidentally pick on me first. Like maybe they weren't looking for Microsoft, they were just looking for a computer, and by putting my link at the top, it might get some hits and get some results. Nothing against either Microsoft or Apple, just throwing that out as an example. The idea being that you can have advertisements in your search results. Make sure you look at those specifically to find the word sponsored or to find the word ad, so that you understand those are advertisements. Those are paid positions. They are not in the ranking by merit. They are in the ranking because they paid to be at the top. All right, when we talk about our connections to websites, there's a couple of protocols, a couple of words I want you to understand. The first two important ones are obviously Hypertext Transfer Protocol and Hypertext Markup Language. Starting with our protocol, Hypertext Transfer Protocol is the protocol that we use to connect to websites. Again, HTTP, HTTPS are the Hypertext Transfer Protocol and Hypertext Protocol Secure. These allow you to connect to websites. HTML is our Hypertext Markup Language. It's a language similar to Java and C# and C++, different languages. It is a programming language. Understanding it's a language may make it easier for you to recognize it. When you see that L at the end, it's a language. Hypertext Markup Language uses hyperlinks to link to additional sites, and it uses HTML tags to describe how the text and graphics should appear. They're controlled by the W3 Consortium, who keeps track of all of the HTML tags and make sure that you understand how those tags work and how they should look when the site is presented to your web browser. Again, Edge, Safari, Chrome, web browsers, Firefox. Those are the ones that are going to open HTML pages, Hypertext Markup Language pages. When they were coming up with HTML, the standard that they used prior to it was called SGML, or Standard Generalized Markup Language. So it's a markup language using tags similar to HTML. It was the precursor. It was the markup language we used first, and then we built HTML out of it. So SGML came first. It was actually the original standard of both HTML and XML. So SGML came first. HTML and XML both came out of that. XML, the X actually stands for extensible, EX, but EML just seemed annoying. So XML is extensible markup language. XML is usually used in large business applications, and while it is similar to HTML in that it does use tagging, it also allows custom tags so that you can do data modeling in your tags. This is used a lot to send data back and forth in API connections to be able to connect directly to a database on one side or a website on the other, and you can send things using XML. JSON is used in the same way, but we're not going to talk about it in this course. CSS stands for Cascading Style Sheets. Style sheet describes the presentation and layout of your web pages. The part that makes it cascading in that you can put multiple CSS pages and the rules will change depending on which order they're in. So we'll start with the first file, and then the second file, if it overwrites any of the first file things, that's okay. We'll still keep moving down, and then the third file, if there is one, may overwrite some of the second and some of the first pages, and that's okay as well. They cascade down. So you can have multiple pages. The great thing with CSS, if you've ever taken a web design class, it can make your entire site consistent by just changing one set of CSS files. So my presentation and layout of my entire page, where are my margins, what's my background color, what font style am I using? We're going to make it all consistent by having one single CSS page or a series of them. We can have like a reset page and then one for the overreaching and then one for individual pages, but we can have a consistent look and feel to our site. In the olden days, before we had CSS pages, you would have to make all of those layout changes individually. And if you decided to change the header color of one page from red to blue, you'd have to manually go into every other page and change it from red to blue. Now, with a series of CSS pages, you just have to change one page. JavaScript is a language. It's a scripting language similar to Python that allows you to embed code inside of your web pages. It's not enough to have your web page be static. It needs to be dynamic. It needs to move, and it needs to allow you to click things or move the mouse around and have things feel like they're changing or moving based on your movements, on your clicking, whatever you choose to do with your website. JavaScript lets you do that. JavaScript is a language that allows you to interact with websites. By the way, JavaScript has nothing to do with the Java language. They are completely irrelevant to each other. They don't have anything to do with each other. JavaScript is a scripting language, is an uncompiled scripting language that is used specifically in web pages to be able to interact. One of the other useful things with JavaScript is that we can communicate with a back-end database using languages to connect and get information from your page, like a web form, collect it, combine it, and send it back to the database, and then get information from the database and use that information again to describe our page. If I wanted to make my page custom or dynamic, you would use JavaScript in that point to be able to make your page dynamic. The last of our protocols is called our SOAP protocol, our Simple Object Access Protocol. The purpose of SOAP is to be able to set the rules for web-based messages in XML. It allows for direct interaction with a web server. So we can talk to the web server writing code rather than having to go through a web page. This is useful if you need to make a custom web page based on some other subset of data. So if I need to be able to connect to a web server or a database server, get some data and bring it back, I can use the SOAP protocol to be able to do that with getting the HTML out of the way. Then I can take that information and write something custom. So the purpose of SOAP is to be able to set up a set of rules for web-based messages using XML and to allow direct interaction with your web server. When you want to transfer files over the internet, you can sometimes go to an HTTP page and drag and drop a file on there, and it's going to upload the file to a specific position. Most people don't want to have to go through an HTTP page. They want to be able to log in some way to the other site, the client server site, log into the server, and be able to send files directly that way without all of the fluff of an HTML page. So file transfers between a client and server can be done with FTP, the File Transfer Protocol. Remember, it's a protocol. It describes how to do the movement. Couple of different ways to do that. The two most common is using actually a command prompt. Using CMD, you can just type FTP to get into the FTP utility that came with Microsoft. You can use the FTP if it's open on a website. So you can go to your web browser, Edge, Safari, Chrome, and type in FTP // and whatever web server or file server you need to attach to, and connect that way. There's also a third-party software called FileZilla that is also really useful for FTP. So it allows you to say, where do you want to connect, does the connection, the handshake, and allows you to do that connection. We've explained to you TFTP before, but Trivial File Transfer Protocol is the lightweight version of FTP because it uses UDP instead of TCP, and it's connectionless. So it's the easier version. Trivial is a little bit difficult to kind of wrap your head around. Think of it as connectionless versus connection-based. So TFTP uses UDP, FTP uses TCP. There is also a secure version of File Transfer Protocol, which is the Secure File Transfer Protocol, or SFTP, which allows you to do login authentication and make sure that you can control who is connecting to your file server, who is getting files, who is changing things. The last FTP thing is what we call anonymous FTP sites, and these are open literally to anybody for either up or download of files depending on how they're configured. In other words, you can have files that are out there and you don't have to log in and get permission. This is kind of the WikiLeaks concept. When data's out there, you make it available to everybody. Everybody can get to it. Everybody can download it. There is no control over that. Uploading is also a big thing with anonymous FTP sites. I can upload files directly to the anonymous FTP site, and they're available there. They're also available for somebody to take and modify as necessary, but because there's no authentication controlling anything. The list of commands here are things that you can run in the command prompt, running the FTP utility. So you can use a change directory, you can use a help, you can use an open, a put, a password, so on and so forth, quit and buy to exit or close. NNTP was a lot more popular before, but that doesn't mean it's not still used. NNTP is the Network News Transfer Protocol, which was designed for news messages. This was your news results coming out. You could go into different directories and news groups and categories and discussion groups and look up all of these. A lot of sites have created websites that do this so that there isn't as much need for it, but it's still available, it's still a protocol, and it's still used. You would use a client of some version to access, download, and read the contents. This is done a lot in research or in trying to find specific information from specific sites. If you knew it came from the Wall Street Journal, you could go to the Wall Street Journal Network News Transfer Protocol site and be able to see the different news groups that were available on that site. So they give you kind of a discussion group concept. So news groups are categories and groups of articles, and then you can have individual discussion groups therein. To do that, you would go ahead and use a client to access them. In 2010, Microsoft actually removed their news group using NNTP and replaced it with the Microsoft Community. Microsoft Community was the one that was supposed to take over for the version of being able to use news groups. And you can go in there and you can search the community for different pieces of information. Email is something that all of us use all the time, and you may not think really a lot about how it's used. Important protocols that you need to keep track of when it comes to email. First is the Simple Mail Transfer Protocol, SMTP. This transfers plain text email from your client to the mail server, one direction. So we're going from your computer, your phone, over to your mail server, the direction of from you to the mail server. Once it gets to the mail server, it runs through where does it need to go, and it delivers where it needs to be. To receive your email, to obtain it, you use either POP, Post Office Protocol, or Internet Message Access Protocol, IMAP. The way POP works, and there's 3 versions of POP, there's POP, POP2, and POP3. POP is designed to access the mail server and specifically download all of your emails. It does not leave them on the server. This is the point of Post Office Protocol. If you have multiple devices connected, say you get your email at home on your computer, you also get it on your phone and on your work computer. POP doesn't work for this because every time an email is downloaded, it is no longer on the server. You cannot get it on a secondary device. Most email has transferred away from POP and into Internet Message Access Protocol, or IMAP. IMAP keeps your mail stored on the server forever unless you tell it to go away. Every time you download it, it's still on the server. So you can download it to 5 different devices and it doesn't matter. This is used most of the time for emails these days because you want to have the history of your email available on the server at any time. It used to be that you would only get email on one computer because you would only have one computer and it wasn't a big deal. But using the internet these days, everybody has email on your phone, on your work computer, on your home computer, and you can't have it downloaded and kept on your local machine if it's going to be downloaded on 3 different machines. So we're going to use IMAP for that instead. And the big difference, Post Office Protocol downloads it, takes it off the server. IMAP will leave it on the server until you tell it otherwise. The MIME is the Multipurpose Internet Mail Extension, or MIME. MIME is the thing that's going to encode all of your attachments, any of your graphics, any of your JPEGs that you're attaching to your email, any of your little smiley emojis. Remember, just plain text is going with SMTP. We have to find a way to get it there for all of the other things. So every time you have something else attached to your email, that's going through the MIME extension to make sure it encodes it correctly. Every email system has to consist of a mail server and a mail client. The mail server, usually provided by your ISP or whoever it is that's providing your email, keeps track of all of your emails, all of your users on their server. Your client allows you to log in with your email address and password to be able to retrieve that email. Obviously, your email format, I don't need to explain that to you. The structure of an actual email, and there's an image in the book which I would like you to make sure you look at, which shows you the headers of an email itself. Every email contains tags that tell it who it was to, where it was from, what is the subject, and what is the actual text. Those different parts of the email itself. Your header will always tell you these pieces of information. So if you receive email or you are sending email and you want to check out the header, if you suspect that it's spam, if it's not from who you think it is, you can look at your header to be able to determine what the actual email address it was sent from. Your mail filter is going to block or filter your unwanted messages, spam. So spam, spammers send spam. They're unwanted email messages. They're stuff you don't really care about. Most web filters out there, or mail filters, are going to be run at the ISP level, and they're going to do a huge amount of filtering before they get to you. You may be surprised at how much web filters or mail filters are blocking of stuff that is supposed to come to your mail. If you believe that there is mail that should have come to you and didn't, you can always go to your ISP and say, I'm looking for this email from this person. Did you block it? Did you assume that it was something that was spam? Because it's not, and you need to go clear that. So being able to unblock or go to your mail filter, you may have done that before where you were looking for a password reset or something to come in and it never got there. That usually happens because your ISP, whoever is supporting your email, whether it's Microsoft 365 or your individual ISP or Google or Gmail, they blocked it. They thought it was spam. So they just didn't send it to you in the first place. You want spam filters on. There is a huge amount of spam that flies around the internet, and you would really prefer not to get most of that. With your mail filter, you generally send them with rules. So you can either block an individual sender, an individual domain name, or a specific message rule. So if something in the subject says, buy now or something like that, something you feel is a spam, you can set up filters with your client to be able to say, please filter out any of these and send them straight to spam. I don't want them. You could say the same thing for things from specific domains. If there's sites that are sending you information that you don't want anymore, you can right-click usually in your client and be able to say, block this domain, block this sender, put them in spam, move them directly. I don't want to see them. Your mail gateway is an actual piece of software that connects two incompatible email systems. So if you have email from Office 365 and you have email from Gmail, and those don't generally work together, a gateway will allow you to connect the two. So hopefully that helped you to understand a little bit more about web servers and the services they provide. There's some review questions. Obviously, the study guide questions, there's not that many. I think there's 7. The lab activities. So 56 through 62 are the lab activities associated with this chapter. 56, 58, and 60. The procedures in those are optional, but the review is required. Remember, we've talked about this. You can usually do the review questions by reading the introductions, reading through the procedure without even doing it, and understanding how those review questions are done. So the review questions are required. If you choose to do the procedure, that's great, but you don't have to, unless you want to. They usually have to do with peer-to-peer networks. Page 50, or Lab 57 is actually building a web page. Again, you can do this in Notepad. It is not that hard. So go ahead and create a web page for 57. 59, 61, and 62 use Wireshark using the sample files 11 through 13. So those are your projects for your labs. You would need a peer-to-peer network. If you have one for your computer, you need internet access and, of course, Wireshark. And some sort of Notepad type situation to be able to do your web page. The study mate is available, and please don't forget to take the quiz. Thank you so much for watching this Chapter 13 on web servers. Please come back next time for Chapter 14. Have a great week.